Right, now, before I do this, kind of big solve for x, let me just take you back to one we did a while ago, which was this. Do you remember this? 6x plus 9 equals 39, okay? 39, there we go. So I took away 9 from both sides, all right? Remember, I've got to get that x by itself. This here, I've got to get that by itself. So I took away 9 from both sides, so that's 30. 39 take away 9, and this is 6x still on the left. Then we divided by the number next to the letter. Okay, remember this? Divided by the number next to the letter, x was equal to 5. Okay, 30 divided by 6. Now then, look at this one. All of a sudden, you've got x's on different sides. We've always seemed to solve it where the x is just there by itself. We've got some other numbers that we have to get rid of, but we haven't had x's on both sides before. Well, this one does. Now, I tend to think this. Okay, first of all, look at this. You've got x's and numbers, either side of the equal sign. Now, you always want for these, you want the x's one side, the numbers on the other. Doesn't matter if it's x's this side and numbers on this side, as long as they're on separate sides, okay? So, you want to get the x's by themselves on the same side. Again, with this one, it was already there. It was already on the left. We just left it there. Okay, we put the 9 on the right. Now, ask yourself this. Where's there more x's? Now, I can see there's more x's here, okay? 8x is more than 2x. Right, so let's actually try to solve it by putting the x's on the right-hand side, because that's where there's more of them. And the reason why we do this is to keep that number next to the x positive. Doesn't really matter which side you put these on, but I'm going to think to myself, okay, I like the x's there because there's more of them. If that 8x is on the right, I don't want the 2x on the left, which means I'm going to subtract a 2x because it's a positive 2x, okay? So that has gone, but I'm going to subtract a 2x from this side. Again, here's the equal sign. I've still got the 14 on the left, but now I've got 6x, 8x take away 2x, 6x on the right with still a 2. Okay? Now great, okay, great. I've now got that 6x by itself on one side, just like this was by itself on one side. So I'm going to keep that there. Okay, that's fine. I need to get rid of the 2. I don't need to get rid of the 14. The 14's fine on that other side, okay? So again, 14's on the left, 6x is on the right. I don't want the 2 on the right. I subtract it. Subtract a 2. That's 12. 12 equals 6x. You divide by the number next to the letter. Can you see x is going to be equal to 2? So x equals 2. 2 equals x, okay? And that's it. So again, you kind of look for where there's more x's. Let's have a look at some of these. And there's probably some more over the page. Let's have a look. Here we go. Okay, let's do this one. All right. Again, looks like there's more x's on the right. If it's on the left, keep them on the left. I'm going to keep that right there. If that's happy there, I don't want this over here. Okay, which means I'm going to do this. So that's 3x. 5x take away 2x, still got the negative 12 on the right, still got the 9 on the left, because that has gone, okay? Now can you see, again, that's fine where it is, 3x. I don't want the negative 12, I add a 12. Add a 12. So 9 and 12 is 21, still equals 3x. If you divide both sides by the 3, which is the number next to the letter, you're going to get x equals 7, aren't you? 21 divided by 3, x equals 7. Okay? Now, just out of interest, I mean, this is kind of a trick one. Look at this. Negative x, negative 5x. Where's there more x's? Think about it. There's more x's on the left. Negative 1 is bigger than negative 5. I would add a 5x to both sides to get rid of it on the right. Add a 5x on here. So negative 1 add 5x, or 5x take away 1x is 4x. Positive 4x. And that's why I did it. I always like to have a positive number next to the x. There's still a 21 at the front. There's still a negative 3 on the right. So again, look what I did. I just got rid of a negative 5x by adding a 5x. That's all I've done. If I add a 5x over here to a negative 1x, I'll get positive 4x. Okay? I take away 21 because I'm going to keep this 4x on the left. I don't want the 21 on the left. Take it away. Take it away. That's going to give me negative 24. So 4x equals negative 24. Can you see if you divide both sides by 4, squeeze it in down here, x equals negative 24 divided by 4 is negative 6. Okay? Can I squeeze any more in? Oh, let's just do this one here, 19. So I've got a 3. Remember, you do not do 3 take away 2, which is 1. You don't do that. You do a distributive law with a negative 2. Negative 2, okay? So 3, that's fine where it is. What's negative 2 times x? It's negative 2x. What's negative 2 times negative 4? Careful, that's positive 8, isn't it? All right, look at that. And it still equals 5 minus 2x. Okay? Nothing to do on the right. I just did this distributive law on the left. Now look, I can combine like terms. Look, there's a 3 and an 8 here. That's 11. Still got the minus 2x. Oh, I've just seen this one. Okay, this is a trick one. I hadn't realised, but as long as you're doing the correct work, okay. Now look, okay, that's fine. 11 minus 2x, 5 minus 2x. If you were to say to yourself right now, if I add 2x to both sides, now watch, if I add this 2x to get rid of a negative 2x, so it's gone, and add a 2x over here, well, wait a minute, that's gone. You go, what did I do something wrong? No, you're left with 11 equals 5, which makes no sense. There's actually no answer to this one. This is a trick question. There's no solution. But as long as you can see, you know, do all the correct working out, distributive law, you know, x's one side, numbers on the other, it just so happens there's no x's. Okay, so I think that's pretty much it for everything, hopefully. Okay, that's it.